Okay, thank you, Vivian, for the introduction. As you see here, the title of my presentation is Smart Connector and Scheduler on the Cloud. I have done this work with my colleagues, Dr. Ian Thomas and Professor Hans Schmidt at the Armat University. So we have a problem. Researchers from the School of Applied Science in Armat University have an executable code. So they use this code for doing Monte Carlo simulation. So these researchers would like to have a scalable, flexible, and fast computing environment. So one of the things that we do at the A-Research office is that we move some HPC computations to the cloud. So luckily, when we examine this Monte Carlo code, we have identified two things. The first one is the computation is embarrassingly parallel. What it means is when you run it on multiple processors, these processors should not communicate with each other. And the second point is it was not I/O bound. So this makes it a very good candidate to be moved to the cloud computing environment. As our cloud provider, we have selected Nectar. The reason for our selection is that Nectar provides free but limited cloud resources to Australian researchers. So once we have identified the suitability of the simulation to be moved into the cloud environment, the next question was that why should researchers care about cloud computing, and what should they know about cloud computing? So from the researcher's point of view, it's all about fast computation, cheap computation, scalability, and overall, it's about maximizing performance. Should our researchers do a literature survey on cloud computing? Should we expect them to have advanced training in cloud computing? In our case, from our point of view, we should not. There should be familiar interfaces and tools that help researchers, that enable researchers to leverage the advantages of cloud computing. There should be a simpler way of packaging their software environments and making it accessible in the cloud. So this is our solution. So what you see here is what we come up with. We have written a set of command line tools. So the researchers, they are physicists, by the way, and they are familiar with command line environments. They usually write scripts, so it's not a big deal for them using command line scripts. So here, what we come up is there is a tool which enables them to create as many virtual machines as they want using a single line, is a single command. So actually, of course, the maximum number of virtual machines they can create is bounded by the quota on the Nectar cloud. And once these machines are created, then then there will be another command line tool for setting up the virtual machines. So this setting up includes installing the Monte Carlo program and also its required dependencies. So once this is done, the next step would be to run the simulation. The researchers could run the simulation as many times as they would like. So once they are done for the day, they can terminate again the machines which were created here using a single command line tool. So this basically addressed the requirements of our researchers. But when we look at our solution, we said, look, probably there might be a need to generalize the solution. So these researchers, first of all, they repeat the whole process many times. They may also do the same process with a slight variation. They may want to do the same thing, but for other scientific code. Instead of doing their simulation doing Monte Carlo simulation, how about if they want to do image rendering? And also, we also thought, if there are researchers who do experiments using Monte Carlo simulation, the tool that we came up with should be helpful for them as well. So this is when we come up about the idea of smart connector and smart scheduler. So what is a smart connector? So a smart connector is basically a connector which connects a researcher's desktop app to the cloud. Its basic idea is it should be able to talk to the cloud service on behalf of the researchers. It emphasizes on cloud access abstraction. So here we have a smart connector, by the way. We have a prototype, a concrete implementation of a smart connector. But this smart connector could be implemented in any ways. However, irrespective of how it is implemented, it is important for that smart connector to respect the architectural style of the underlying computation. It should know for that computation what are the stages, how are each stages are constrained, what are the constraints, and what's the trigger. And it should also provide a predictable performance. Let's go back and see our solution. So in our solution, we have 5 stages. We have the create stage, we have the setup stage, we have the run stage, the collect stage, and also the terminate stage. So one thing is, like for the smart connector, regardless of the type of the smart connector, each smart connector should have these yellow boxes. It should be able to create multiple VM instances. It should be able to set up those VMs for the next computation. It should be able to terminate it should be able to terminate the created VMs. Because the smart connector, the basic idea is it should be able to handle all the cloud-related processes on the behalf of the researcher. So the variation point is here. When you look at the green box here, that's the difference. Running, in this case, in the simple example, what we have is just running a basic Monte Carlo simulation. There is nothing more. But this could be very sophisticated. You could have a very sophisticated smart connector. Here, this is our basic smart connector. And this one is what we call the daisy chain smart connector. So in the daisy chain smart connector, we have five type of stages. So the workflow is how they are connected with each other is completely different. So for us, the smart connector, as long as it can create VM instances, set them up, let our researchers do whatever that's needed to be done in the middle, and then able to terminate that is sufficient. That would be, we think that would be very helpful. That by doing this, we take away the need from our researchers to learn a new stuff, a new tool. So if this is a smart connector, then what is a smart scheduler? So the smart connector, it only knows about the existence of a cloud computing environment. It doesn't know about whether the cloud environment is the Nectar cloud, whether it's Amazon, whether it's Rackspace. It has no idea about that. That is the work of the smart scheduler. The smart scheduler is aware of resources. It knows about Nectar. It knows about Amazon. It knows about what are the requirements of the computation, what are the requirements of the simple smart Monte Carlo connector, and what are the requirements of the daisy chain smart connector. It should be able to know that. And also it should be able to know that about what are the services provided by Nectar. So by having these two information, it should be able to rank the cloud provider which are suitable for that specific computation. Then, of course, once it's ranked, it presents the choice to the user for the final decision. This is very important, because take the case of the choices between, it could be the first rank could be Amazon, the second one is Nectar. So in Nectar, at the moment, yes, you don't pay right away. There is no cost associated with Nectar at the moment from the researcher point of view. But if you go to Amazon, you have to pay for it. You need to have some credit set up. It could be from your institution, or it could be your personal. You have to pay for it. So if the smart scheduler will say, look, we have seen your requirements. You want to create 20 VMs. You want to do the daisy chain. I think we recommend for you, Amazon would be the right thing for you. However, you can do the same job in Nectar as well, but bear in mind that you have access to 2 VMs at this stage, then it's going to take a little bit longer. So there might be other parameters as well. This is just an example. Then finally, once the final decision is made, there it is. It tells the smart scheduler tells to the connector, okay, do everything, do the creating the VM, setting them up, and the running, and also the terminating, probably in Nectar or in Amazon. So for the smart scheduler, it's just what we have is you can have a lot of parameters, many things. You can consider many things. There are, for example, 13 architectural types you can consider. You have combinational logic, you have map reduce, you have linear sparse. We don't have all that implemented yet, but this is a work in progress. So when we start this work, we were going to give a solution for our researchers. There's nothing more. So we have seen their problem. We wanted to put it to the cloud, and then we gave them a solution. However, we gave them familiar interfaces, and you give them familiar concepts so that they can start enjoying the benefits of cloud computing. It was a very simple solution. But we see a potential in it, and then we try to generalize that solution so that it can be accessible, it can be usable by other researchers as well. So what we come up with, it's an open source solution, and it's also a work in progress, and it's part of Nectar Bioscience Data Platform project. Actually, the next talk is going to be about this platform. So in this platform, basically, our idea is this is a highly available cloud service which lets researchers share data, store data, retrieve data, do some processing with it, make some more modification, and store data again. And then they can also publish their data and share with their collaborators. So in this bigger scheme, we are staying here. This is where we see the smart connector and scheduler will play a role. So for us now, especially in this presentation, we just want to start a conversation, with the researchers, what they want, what they need, what type of smart connectors do they want to be built. Like we are not going to build, like a researcher at MIT is not going to build a smart connector, all type of smart connector. We have two smart connectors at the moment, like the basic Monte Carlo smart connector and the daisy chain smart connector. But we want to share that with other researchers from Monash, from CSIRO, or from anywhere else, so that they can do the same task. So that the e-research office at the Monash, they don't need to build the smart basic connector, they just use ours. But they will also start building other smart connectors that would be helpful to others as well. So in this case, we'll have a lot of smart connectors, and then it will be much easier for our researchers. So software engineers, developers here. So here is very good kind of proposal for you. And also for the researchers, you should come and talk to us and say, this would be cool if you add this thing. Maybe this is very simplistic. Maybe this is complicated. You should make it simpler, or this is too simplistic. It doesn't capture our requirements. And, it's to have this kind of conversation, I think it would be very great. And thank you for listening.
We have 5 minutes for questions.
Yes, please.
Yes, please come to the mic.
Everybody from New Zealand's Victoria University over here in Australia. How much of the flexibility in your smart connector is going to be taken away by the fact that you will have data on a storage platform that is connected to Nectar? It might not be on EC2, so if you want to have a scheduler that comes up and says, yes, the best place to run this is at Amazon,
yes,
but you haven't got your data at Amazon, you've got it in Nectar.
That's right.
That's going to override some of the flexibility in the scheduler choices for big data sets. Is that an issue you've considered?
Actually, this is, you see, like, of course, there are many requirements. There are a lot of things that we need to take into consideration. If that's the problem, for example, if the data is coming from Nectar, I would imagine the scheduler should be able to point that out. It is from the, if it's not accessible from Amazon, the choice would be, I would see, it would be the Nectar, because the data is other in the Nectar cloud. That unless there is other added benefits to take the data from the Nectar cloud and then accessing to Amazon. And the other thing is, in this case, when I make this presentation, at the moment, we are just looking at homogeneous computation. So all the computation either goes to Amazon, which means all the data that are needed, the executable codes that can be transferred to Amazon or its Nectar or its Rackspace. But in the future, definitely, we are also looking at heterogeneous computation as well. There might be some aspects it's better to use Amazon, which you want to get quick performance, fire up, collect all the results. But there might be some other part of the computation. It would be to work on Nectar, 2 VM instances should be sufficient, or whatever is allocated. So that's what we're thinking.
Hi, Nigel Ward from Nectar, who's funding the project. So great to see you talk.
Oh, nice.
But I know the bioscience data platform project that Steve's about to talk about is
Yes.
not. It's great that you're doing some computation on the Nectar Cloud and Amazon Cloud,
That's
but
right.
it's also interested in doing computation on high performance computing, like facilities like Massive.
Yes.
Is that part of the scope of your project as well, doing scheduling onto those sort of resources?
So, if it is required by the researchers, it will be part of the thing. So at the moment, what we have is, if it is required by the researchers, if they need that, then we'll look into building the smart connector with that job. That's what one, but probably may not be necessarily related to the bioscience data platform. Maybe Steve may need to answer to this question, but overall.
Right now that it's likely to be needed, yes.
Yeah.
Yeah. Okay. But researcher-led. Yeah.
Absolutely.
Yes.
I've got another question, if I may, Vivian.
Yes.
So you mentioned the basic connectors, a MapReduce connector. What technology are you using underneath that? Are you using Apache Hadoop or
Which one?
the MapReduce?
Okay. Actually, when in that slide, when I put the, sorry, I can't go back to my slide. It's fine. So on that slide, when I show the MapReduce is for the basic smart connector in combinational logic, there are 13 types of architecture which are identified. I'm just making a point that, this basic smart connector is kind of satisfies the requirement, the description given as MapReduce. But the other one, the daisy chain, is combinational logic. I'm just not referring to the fact that we are using Hadoop or anything else for the basic smart connector.
But what have you implemented it with?
For that one, no, we have not used MapReduce. We just use we send each independent processes to individual VMs. That's what we have done.
Okay. Thank you.
All right.
Thank you. Please join me in thanking Iman from.
Oh, thank you.